Here we have some inequalities that require us to use the multiplication principle for inequality to solve them. In the first one, we want to get x by itself, and the only thing happening is it's multiplied by 1/2. So we will multiply both sides by 2. And as long as that number is positive, everything holds as is. In other words, we don't have any special handling with changing the direction of the inequality symbol. The 2 times 1/2 cancel one another out, leaving x, and multiplying a negative times a positive, we get a -2. Graphically, we are starting at -2 but not including it. To indicate that, we'll put a parenthesis, and we want all the values that are greater than that. So we have the set of numbers here continuing infinitely towards positive infinity. The translation of that graph into an equivalent interval notation is -2, positive infinity, smallest value first. We're not including the -2, and infinity, because it doesn't end, always has a parenthesis as well. In this next example, the variable is being multiplied by a -3. To undo multiplication, we divide, and we want a +1, so we'll divide by a -3, and here's where that multiplication principle for inequality requires us to reverse that inequality symbol whenever we multiply or divide by a negative number, which is the case here. So our less than becomes a greater than. The negatives cancel out. 3/3 is a 1 times x, or x. Positive divided by a negative is negative, and 15 divided by 3 is 5. So our solution here are all numbers greater than or equal to -5. We're including -5 and want all of the values greater than. So we'll use the arrow to indicate this continues towards the positive infinity direction. Translating this into an equivalent interval notation, the smallest value, which is included, we use the bracket for inclusion, headed without bound to positive infinity, and infinity again always has the parenthesis.